It's important not to become muddled by what all the different symbols and names and everything are. So this table was just to remind you. So charge is a capital Q, resistance is a capital R, and current is a capital I. You measure charge in what unit? In coulombs. You measure resistance in ohms. You measure current in amps or amperes. The symbol for coulombs is a C, the symbol for amps is a capital A, and the symbol for ohms is an omega. If I take a look at this diagram, I'm going to do my colors. I'm going to go until I hit a resistor, or, for example, something like an open switch. Now, if the current's not flowing, the resistor is actually not resisting. So I can go straight through that until I hit the open switch. Now I take a look at what happens with my switch open. Between E and D, I am told that the potential difference is going to be equal to 12 volts. You can see between E and D, the energy is on a blue line and on a pink line. So there's no change in energy between anywhere on that pink line and anywhere on that blue line. So I can say between F and G, I am on a blue line. There is absolutely no change in energy, so that's 0. Between F, sorry, that was between F and G. Between F and H, I would put a voltmeter between blue and pink, so it would be exactly the same as between blue and pink up there, so that would be 12. And between G and H, I have got, it would be the same as if I had connected the voltmeter between E and D, so I land up with 12. Now what happens if I switch, close the switch? So I'm going to do my colors again, but this time my switch is going to be closed. So I'm going to come around until I hit a resistor, and I'm going to come around until I hit a resistor. Again, I have been told that the potential difference of this battery is 12 volts. So between E and D is still going to be 12 because it doesn't matter, well, there's no internal resistance, but otherwise it would be, it might have dropped a little bit now that I closed the switch, but we are talking about a resistance of the cell is negligible, so we don't have to worry about that. So that's 12 volts. Then between F and H, I am once again connecting between pink and blue, so it's 12. Between F and G, I am also connecting between pink and blue, and again, those are two energy differences at 12. And between G and H now, I have got no difference in energy. They're both on a pink line, so that is 0. Got the circuit diagram over here. What is the potential difference of the battery? Because they are connected in parallel now, my potential difference of the battery is going to just be 6 volts. There's no internal resistance in this particular story. What is the total resistance of the circuit? Well, it's a very simple circuit. They're just two resistors in series, so it's going to be 5 plus 3, which is equal to 8 ohms. What is the ammeter reading? Well, my ammeter reading, I is equal to V divided by R. What V? The whole circuit divided by the resistance of the whole circuit. And I land up with 0.75 amps. Then what about this voltmeter reading over here? The voltmeter is connected over the 3 ohm resistor, but the current is able to go through that 3 ohm resistor, so it's the same current, and V is therefore equal to I times R, the series current multiplied by the resistor over there, and we land up with 2,25 volts. What is the quantity of charge that passes through the 5 ohm resistor in 5 minutes? Q is equal to I times T. The current is 0.75, and the time in 5 minutes is 300 seconds, and I land up with 225 coulombs. And the amount of energy generated, remember what energy generated is? It is work done. So work done, and it's generated, which means it's coming out of the battery. So I'm going to use VI T. And that is going to be equal to 6 times 0.75 times 10 seconds. And I land up with 45 joules. Okay, we've got a group of students. They want to use a ticker timer that's marked 6 volts, DC 2 watts. This means nothing to somebody who hasn't studied science. So how do I decipher this? This means that 6 joules of energy are going to be transferred to each coulomb of charge. DC means direct current as opposed to AC, which means alternating current. And 2 watts is the power. So we can say that 2 joules of energy are transferred every second. That's what that means, and that's how you can unpack that. So what is 6 volts? 6 volts means 6 joules to each coulomb. DC is direct current. And 2 watts is 2 joules each second. Unfortunately, we haven't got a 6 volt source. We've only got a 9 volt source. So now what am I going to do to decrease that voltage? I'm going to put a resistor in here, and I need 6 volts across the ticker timer, and I am going to need 3 volts across the resistor. They want to know the resistance of the resistor. I've still got very little energy, at least information. Why don't I try and work out the actual current going through there? So I'm going to say current strength is equal to, well, I know that power is equal to work, at least potential difference times current. So current is going to be equal to power divided by potential difference. So that's going to be 2 divided by 6, and that's 0.33 amps. So if I had an ammeter on here, it would read 0.33. Now I've got quite a lot of information about this resistor. R is equal to potential difference divided by current strength. The potential difference is 3. The current strength is 0.33333333, which I left in my calculator, and that then turns out to be 9 ohms. We've got a multi-plug. It is protected by a 15 amp fuse. It's important that we understand what's happening here. I've got my, whatever the current is going through the heater and the iron together have to be less than 15 amps, because what does a fuse do? A fuse is going to melt the minute there's too much current in it. So let's try and work out what each of these readings is going to be. So we get told that the heater is 220 volts, 2000 watts, and we're told that the iron is 1000 watts, and it's also 220 volts. So with that information, I'm able to work out the current on each of those branches. So the current is going to be equal to power divided by potential difference in each case. So the first one is 2000 divided by 220, and that's going to land up being 9.09 amps. And then on this bottom branch of the iron, I've got power divided by potential difference, and I'm going to take 1000 watts, I'm going to divide it by 220, and I land up with 4.55 amps. When I add these two together, so that's coming from 909 is coming from the top branch, 4.55 is coming from the bottom branch, and if I add those two together, I land up with 13.63 amps on the main branch. 15 amps is greater than that, so that fuse will not blow and everything will be fine.